Proxima B is an Earth-like planet orbiting the closest star to our solar system. What a coincidence! Although conditions on Earth are quite suitable for life, why settle for that when there are other planets that offer better characteristics such as balanced temperatures, fewer deserts, and a greater abundance of water? We're talking about the future of humanity, and scientists have identified some planets as prime candidates for possible colonization. These super habitable planets, as Michio Kaku calls them, are fascinating and pose exciting possibilities for our future. Michio Kaku, the renowned physicist and co-founder of string theory, is optimistic about the future of humanity and the possibilities and opportunities that these super habitable planets may offer. He firmly believes in the possibility of achieving immortality and, furthermore, aspires that in the future we will be able to colonize other planets and even entire universes. This idea arises due to the need to have settlements in places in case of something catastrophic happens on Earth, such as meteorite impact, supervolcanoes, or ice ages. In about 5 billion years, it is even predicted that the Sun will expand and consume Earth. The first steps to ensure our survival is to leave Earth and start colonizing other planets in our galaxy. The goal is to find Earth-like planets or even better planets called superhabitable planets that have even greater potential to harbor life than our own home. The term superhabitable planet was proposed in 2014 by Reid Heller and John Armstrong. According to them, the mere location of a planet within the habitable zone of its star is not enough to determine its actual habitability. Superhabitable planets are specific celestial bodies that offer a higher potential for harboring life compared to Earth. The common belief is that the Earth, as the only known planet with life, meets the psychochemical parameters necessary for the development of life. These parameters are key to life as we know it, and one of the essential elements is the presence of liquid water. It is for this reason that we search for exoplanets similar to Earth, in the hope of finding places where life can also exist. However, it is important to recognize that other types of planets may offer conditions equal or even more conducive to life compared to Earth. Contrary to the notion that Earth represents the pinnacle of planetary habitability, a superhabitable world could also be a mood with a richer range of flora or fauna compared to our own planet. Such a world would be shown as a higher degree of environment conducive to life. It is also important to note that not all rocky planets located in the habitable zone of a star are automatically habitable. Habitability depends on a variety of factors and is not limited solely to similarities with Earth. The concept of superhabitable planets can be complicated to convey as it challenges the assumption that Earth represents the pinnacle of planetary habitability. However, it is important to consider that our planet harbors an impressive array of complex and diverse life forms, suggesting that life can thrive in conditions very different from those on Earth. In the search for exoplanets, research needs to explore indicators that may reveal the existence of superhabitable worlds. Among the promising targets, Alpha Centauri b has emerged. Alpha Centauri b is part of the closest star system to our planet, which makes its potential exciting. However, so far, no planets have been confirmed to be present in this system, much less superhabitable planets. While there was a possible detection in 2012, it was refuted in 2015. Therefore, we do not yet know of any worlds in Alpha Centauri b. However, its neighbors, such as Proxima Centauri, are of special interest. Proxima Centauri is a red dwarf located only 4.2 light-years from Earth, making it an intriguing candidate to host not only habitable planets, but also possible superhabitable planets. Within the Proxima Centauri system, an exoplanet called Proxima Centauri b has been identified as residing in the red dwarf's habitable zone, along with other contending candidates such as Proxima c and Proxima d. Proxima Centauri b is one of the closest known exoplanets to our solar system, which has led to the question of whether this planet could be habitable. However, there are significant obstacles to life thriving here. Several variables complicate the habitability of Proxima Centauri b, such as the activity of the host star and tidal locking phenomena. The light emitted by Proxima Centauri is comparatively redder, which could reduce the interactions with certain organic compounds and decrease ozone production in the planet's atmosphere. This in turn could generate elevated levels of UV radiation harmful to life. In addition, Proxima Centauri b's orbit may be eccentric, which means that in certain parts of its journey, the planet could temporarily fall outside the habitable zone. These fluctuations could negatively affect its habitability potential. Another factor to consider is the presence of carbon monoxide in the planet's atmosphere. If these gases accumulate in excessive amounts, they could become toxic to living organisms. On the other hand, if Proxima Centauri b were to host oceans, higher oxygen concentrations could have a positive effect on the evolution of complex organisms. Tidal forces, due to tidal locking on this planet, would generate periodic cycles of flooding and drying in coastal landscapes. These cycles could trigger chemical reactions conducive to the development of life and promote the emergence of biological rhythms similar to the natural cycles we observe on Earth. In addition, similar cycles of flooding and drying would facilitate the mixing and distribution of nutrients in the oceans, stimulating periodic expansions of marine organisms, akin to what we know as red tides on our planet. It is important to mention that although red dwarfs, such as Proxima Centauri, are exceptionally long-lived compared to our Sun, their radiation is not conductive to photosynthesis as we know it. However, Proxima Centauri b might be able to support a different type of photosynthesis called anoxygenic, although its possibility is not yet fully confirmed. A 2017 study suggested that photosynthesis-based ecosystem on this planet could be about 20 times more productive than the one we find on Earth. The stability of the planet's atmosphere is a major challenge to its habitability. Even before Proxima b was discovered, researchers had been actively searching for exoplanets in the vicinity of Proxima Centauri. In the research conducted in 2008 and 2009, the lack of larger-than-Earth exoplanets in the habitable zone around dwarf stars, which include Proxima Centauri, was noted. Although these stars have on average 1 or 2 planets, only 20% to 40% of red dwarfs harbor planets in their habitable zones. Therefore, our search for a habitable planet in the Alpha Centauri system has not yielded many results so far. While it makes sense to search for exoplanets in the Alpha Centauri system, since it is the closest star system to our home, there are many other options in the vast expanse of our galaxy. So far, more than 5,000 exoplanets have been confirmed, and there are countless candidates awaiting new observations for verification. What do you think? Let us know in the comments box. If you liked the video, hit the like button and subscribe to the channel so you don't miss out on more content like this. Thank you so much for watching, and I'll see you in the next one.